Thank you, Amit. So you already took my first statement, actually. I was going to say that shift left is already there for 10 years. And somewhere last year, me and my team were finding novel ways because like a small child who got a new toy, we were toying around with generative AI. So we were thinking about, okay, how we can play shift left with AI. And these are the results of the research that we have done over last year, and also some of the designs that we have created, and some of the solutions that we are proposing to shift further left in the journey of shifting left and introducing security from the design phase, even before the development phase of software development. Just as a small introduction, I'm Spandan Chandra, a cybersecurity and risk management specialist, and my focus has been in driving efficiency through AI and automation. We'll be talking a little bit about the importance of security from day one. I don't think I need to preach the choir over here, so I will just have a quick glimpse of this one. After that, we will move towards how AI-driven insights can actually help us identify and mitigate security issues really early in the development phase. And then some practical frameworks, how we can actually implement this. So it's good to think that, okay, AI can help us in getting security in the design phase, in the development phase, but how to actually do that? Because putting your data inside an LLM model and getting output out of it is one way to do it, but not the right way, and also not very fruitful way of doing it. Then we will see some practical use cases, how we have actually achieved a couple of use cases that we implemented this framework on, and then the conclusion. To start with the importance of shifting left, these are some of the recent researches I came across from well-known vendors like Forrester and IBM. As you can see, like shifting left is a big priority for the market, for the industry, all the industries right now, and it's costing companies money in security incident and data breaches if they do not implement security by design in their software development process. Some more facts, but these are more towards the evolving landscape. So the governments across the world has also realized that cybersecurity is a big issue for the economy of the country itself. So a lot of countries are actually coming up with the laws to force the companies to have cybersecurity inbuilt. As a fact, there are 20 new laws in the last 3 years across the world, including laws like DORA and NIS2 in Europe. US is also coming up with their own laws. Australia, India, Asia, all the countries are coming up with their own laws around that. And organization, as also told by our colleagues Irfan and Robin before, organizations are facing a big challenge of cybersecurity skills. Whether it be the cybersecurity skills like the professionals, cybersecurity professionals, like lack of cybersecurity professionals, but also the skills within the development teams for cybersecurity itself. That's also quite a big challenge for the companies to overcome. And some interesting fact, when we were reading about cybersecurity and we were thinking about cybersecurity and AI, there are some correlations that we see across the industry in the last couple of years, actually. The two striking ones are the top one and the bottom one, where we saw that 30% of the code which is being generated now is actually being generated by the use of or by the LLMs itself. As our friend Jim told us this morning, that you can create secure code through generative LLMs, but unfortunately that is not the reality at the moment at the ground. So unless we come up with solutions which are creating those secure code, the ground reality is that the code created by the LLM solutions is also as vulnerable as the code created by humans. But the problem is the speed of generation of code is getting faster and faster because of AI. So security needs to catch up as well anyway. And the last one is more towards the organization that are using AI. There has been a decline in their average cost of breach or average cost of incident for the companies who are using AI in their solution. So if you want to have a discussion about the financials with your management, this would be a good start to put in. So when we talk about including AI in the secure software development, it can help us to identify risks and issues very easily. But as I said, if you put details in an LLM model, it gives you the output, but not really tuned output or not what you were expecting. There are a lot of issues of hallucinations that when we initially researched, there were a lot of issues of hallucinations. Also, the data it is using is also not good enough. If you try to ground it, Sometimes you get good results, so that is good enough. But for different use cases, there is a need to think about different types of AI models or different type of techniques for getting the right answers for your solution, for your challenge. The first one is, for example, if you want to identify really early risky areas in your application, or if you want to do compliance matching, like for example, if you have an application, you're using personal data, so GDPR will be applicable to that one. So thinking about around those lines, and then the risk prioritization, if you want to give risk to the particular risk for your vulnerabilities, because I think all of us would agree that each and every organization have vulnerabilities which are in thousands, not even in hundreds. So all the applications are running multiple vulnerabilities, but then the prioritization needs to be really there to understand, okay, what is the biggest risk for our company and what we can tackle. So there are some of the best use cases that we picked up for these kind of use cases. So for example, for identifying risk early, a good thing would be to do, you can also use custom LLMs or general LLMs, but pattern recognition also really helps if you implement pattern recognition on top of those. It really helps to identify the risk early and with the good accuracy and confidence level. For compliance matching, we propose to do RAG, which is retrieval augmented generation, through a knowledge base which you already trust. So for example, if you are working in a company, I hope, or I guess, most of the companies will have their own internal policies and compliance standards. If you have that knowledge-based ground, or if you have your LLM model ground on that knowledge base, the responses that you will get will be much finer as compared to what you get in a normal GPT. And the last one, which is risk prioritization. So for that one, we found out if you use classification model instead of normal LLM models, you get really good results as compared to what you get from a general LLM. So after doing all this, we were thinking about, okay, if we want to do one use case, we have to go this way. If we want to do this use case, we have to go this way. But this way, we will create a huge repository or artifact of ways to actually tackle the problems. What if we try to understand the basic core concept and try to create a framework which helps us tackle all the use cases? So we thought about a cognitive architecture which can help the organizations to tackle all such issues for implementing security really early in the software development phase. The cognitive architecture that we created was in the four stages. The first stage is pre-processing, where the information is taken by the model and identify, okay, what are the main areas that I need to focus on. LLM works in a way that it needs to really focus on what you want it to generate. If you don't give it a proper focus point, it will just hallucinate. So that's really important. So that's the first step. Then the second step was creating a cognitive engine, which is using different techniques like RAG or fine-tuning based on different use cases that you have. That will give you certain level of accuracy in the results that you get in the first go. But that result is also not good enough to actually say that, okay, now this is at the level that an enterprise or corporate can consume it. So what you do on top of that, you implement a decision tree. So think of it like a security person thinking or tackling a security challenge. He or she, based on his or her experience, will think about, okay, if this is happening, then I will take this step. If this is happening, I will take that step. And that decision tree, that logic module, you implement with the cognitive engine itself, and you reiterate that again and again until you get the final outcome which you expect it to. And once you get the final output, then the user, at least in the initial phases, the user needs to validate that output and tell the model that, okay, this is good enough output, I really like it. And that creates a reinforcement feedback to the model itself, to the framework itself. And this way, after a few iterations, the framework works in a way that the output that you get is really good as compared to what we get in the normal GPT or... I guess the AI is not helping us here.
To be sure, this is not part of the program.
Yeah, okay, thank you. So this was the framework that we created, and this is giving us really good results. as I explained, the first step is getting the right information for the model to focus on, and then send that information to the engine. And then the engine does its magic of thinking, okay, this is the challenge that I have. How do I need to fix it? It uses certain fine-tuned models. So if we are fine-tuning a model, usually what we saw was when you fine-tune a model, which is really good model like GPT-4, if you fine-tune it, you just ruin it. So the idea is to, when you want to fine-tune a model, it's better to use smaller models, and the cost that you get in fine-tuning bigger models are even more. So it's better to fine-tune financially as well as from the accuracy point of view. It's better to fine-tune a smaller model, and when you want to have the first go of the challenge itself, it's better to use a model like GPT-4 because that will have more understanding of the challenge and provide the first result good. Then the decision tree logic module, and then the context output, which is generated by the framework itself. The decision tree logic module was the biggest challenging part in this area. As you can see, like getting the data inside, putting it in a model, and getting the output and putting the reinforcement feedback was good enough. But then we thought about how we can make this decision tree logic module really good and really valuable. So this is what we come up with as a logic module. This is not the only framework or module that you can implement. This is one of the ways that we saw is working really good. So for this module is divided into 4 different parts. First is initial security assessment. So think about a developer creating a design for developing a software. At that time, he or she would write certain features, what they want in the solution, or the business will provide them certain requirements saying that, okay, I want you to develop this, this, and this, and these are the business features that I want in this software to be implemented. So based on the keyword and pattern matching, you can already understand, okay, what the eventual software will look like or what the eventual software will be providing as a business value. And then you put certain priority on it and then send it for certain additional analysis. After you send it for certain additional analysis, what you do is you do a compliance analysis check. For example, if the model understands that you're working in a European geography and you are using personal data within your application, or you're planning to use personal data within your application, it will already understand, okay, I need to think about GDPR. If you have healthcare data and you're working in US geography or you're working globally, the model will think about, okay, I need to think about HIPAA as well. And based on that, it will create a list of all the compliance requirements it needs to suffice. On top of that, we actually did an experiment with this one where we also asked the model to think about the OS, ASVS standards as well. Think about those standards. So you can take all the best practices and think about, okay, these are the issues that can happen in the software, considering this is the business use case. So even before coding, even before day 1 of coding, you already know what security implications will be there if you develop this software. The second one is risk profiling and priority assignment. Once you figure out that, okay, these are the security features that I want in my solution, how should I prioritize them? Which are the things I need in my POC or MVP phase? Which are the things I need in my production phase? Which are the things that I can take a gamble and say that, okay, I'll fix it somewhere in the production phase itself? And you need a confidence level as well, because all the result which is generated by AI engines or any kind of AI engine, you really need a confidence score as well. Otherwise, you will never know like how confident the model was when proposing a certain recommendation. And in the end, you have a decision and recommendation. So based on that decision and recommendation, usually the model will provide you certain level of recommendation, but you can also fine-tune that recommendation to your own industry and to your own organization, actually. So if you tell the model that we are working in a financial industry, for example, so the model will understand, okay, I need to talk or think about the financial industry. And then you say, or then you give it some examples of your already existing company literature. It will understand the vocabulary that is used within your company or within your industry, and it will respond accordingly as well. So that your end users, so for example, the business users or the developers within the organization do not need to think about, okay, what is this person telling me? So for example, that we see quite a lot is a friction between the business team, sometimes the IT and security team. That all friction can be also removed through these kind of activities. A simple example of that would be if the model is proposed with a business solution, and the business solution, the initial feature list of the business solution has word like data encryption or API. That is the thing that the model will pick up, saying that, okay, I need to think about API, I need to think about data encryption. And then the model will think about, okay, if we are talking about Europe, I need to think about GDPR. There can be medium severity issues with GDPR considering the features or the application you want to develop. And after that, after further considering the features of the solution or the product documentation of the solution, the model can give a risk score saying that, okay, if you do not do this, so for example, data encryption is mentioned over there. If you do not implement data encryption, there is a high chance of you getting a GDPR violation. And then the final recommendation will come with 90% confidence that you really need to have encryption over there. Then we thought about some potential use cases where we can deploy this kind of framework and where we can generate some value for the business or for the IT teams from this kind of framework. So some of the use cases which we came up with was creating a real-time security advisor. Right now, like we were talking, there is a lack of cybersecurity skills. So the organization which have the information security officers, which have the security champions, those security champions are spread too thin. We were just talking about the security champions having burnout, losing motivation, etc. What if there is a security champion in each and every team who never gets burnout, who is always there to help you out? So one use case could be a real-time AI-based security champion in your team who is helping the team to overcome the issues of cybersecurity or software development security issues. The second one was threat modeling. This topic has been there in the market for the last 5 to 7 years. A lot of companies are working in this area. There are new and new methods of threat modeling coming up. We also thought about what if the model itself is doing the threat modeling for you and already provides you potential attack paths, for example, and already helps you think about what you need to actually do with the minimal effort to overcome that potential attack path. The next one was architecture validation. So at the initial day of creating software, even before developing, usually we create architecture designs to think about, okay, this is how the infrastructure is going to look like. Or maybe in some of the teams, if the application team is, some of the companies, if the application team is different than the platform team needs to think about the architecture, how they're going to develop it. And for those, what we can think about, once they create the platform, if the AI solution can already understand what kind of security issues can happen if you have this kind of platform, it can provide you already building blocks to actually secure your platform itself. And the fourth one which we were thinking about was business impact analysis as well as privacy assessment, maybe a pre-privacy assessment. A lot of companies, whenever a new feature is developed or a new application is developed, you have a process, either solution risk assessment, business impact analysis, or a privacy assessment before you start building the solution, or probably in the initial phases of starting the solution. Some companies still do that before production day -1. But I'm assuming that most of the companies are doing it at the initial phase. What if a solution is there to help you out? You just throw in your project documentation, and the model already tells you, okay, based on your project documentation, I can propose that these are the security issues your security advisor or your security team is going to put in front of you. So you already better tackle them even before you go to them. I cannot explain each and every one of the use case here, but I would like to explain one of the use cases that we worked on. So this was related to the real-time security advisor. And the approach we took for implementing this framework for getting a real-time security advisor. So the first one was creating a knowledge base, helping the model to understand the security in a way we want it to. So for example, if the models are trained on the internet data, the challenge is that there is really good data on internet, there is bad data as well on the internet, and the model cannot differentiate between that good and bad. They are getting better and better. If you already compare GPT 3.5 with 4.0, they're getting better and better, but it's still not to the stage where a corporate or an enterprise environment can really trust on them. So first of all, you need to create that knowledge base. After you create that knowledge base, you need to create a decision pipeline. How will you decide what will be the steps in the process? So if you are doing a security advisory, what kind of industry you are working on, what kind of compliances you need to think about. If there is already existing security guardrails within your company, you need to also let the model or the engine know that you already have certain guardrails within your organization. So for example, a lot of companies have platform teams which already block publicly accessible ports, etc. So you need to already let the model know so that the development team does not even think about creating mitigating those kind of issues because they are already mitigated for you by some other team within your organization. Then integrating it with the tools existing within the organization. Unless we integrate it to the solution or the technology being used by the dev team. So for example, if they are using Jira for creating product features, if they are using Confluence or they are using just Word files or Excel files, we need to integrate with them. Once you integrate with them, the model will start the pipeline and start churning the data from those sources. And then the reinforced feedback. So once the model comes up with the solution at the start stage, the expectation would be that a security advisor timely reviews those recommendations. And for the recommendations which are completely out of the bounds, you should let the model know, like, this is not the way to go. And then continuous reporting. So how it will work within an organization. Before that, how we can create such a model or such an architecture. Here is a very, very high level architecture of such a solution. So you take the base model based on the use cases, you take the base models from Hugging Face or from Azure Marketplace or AWS, and then you give some training data from the existing knowledge base that you have. Once you train that model, it's not necessarily that every time you have to train the model, it depends on your particular use case if you have to train the model. Once you train that model, then you send that model to actually within the company environment. So within the company environment, then you think about the company standards, the company policies. You need to let the model know, like, okay, what are your company standards and policies, and what are the security guardrails already implemented within your company. Once you let the model know, then the model is ready for the interaction with the user. So when the user comes in, the user says that, okay, this is my project report, this is my project documentation. Read this project documentation and let me know what security issues I have in my solution and what I need to do. Or maybe if they are using Jira for creation of their feature list or creation of their user task, the model can already read the user task and saying that, oh, I'm missing an encryption user task over here. Oh, I am missing threat modeling over here. If your company has a mandate that the solution needs to go through threat modeling, and if you do not have a user story saying that you already did a threat modeling or saying that you have planned a threat modeling session, it will already say that, okay, you have not done a threat modeling session. This is the contact of your security advisor. You need to reach out to this person and do a threat modeling session, for example. And then you can get a seamless interaction for the development teams. They do not need to set up time with the security advisor. They do not need to wait for the availability of the security advisor. By the time they are creating their product features or task user stories, they will already understand, okay, we are missing these things we need to take into consideration before we go for the final production. If I think of, so this is more on, that was more on the architecture side. If I think about the process side, because no matter how good solution you create, if you cannot embed that solution in the existing process of the company, you're not going to get success. So how we can implement that within a typical company, we have software development phases, whereas we design, build, test, and release. A lot of organizations are now implementing security and design and build, so that's the expectation as well. Some of the organization might still do it at the testing phase, but the expectation is a lot of organizations are doing security at the design and build phase. At that phase, the model already interacts with the user tools, makes it interactive, and then suggests design improvements for the users, like architects, like product owners, like development teams, to think about, okay, these are the security issues that can happen in your solution. This is a recommended code, or this is a recommended feature you should embed in your already existing code, or you should think about this when you are creating the code. And then at the same time, the model also shows that to the security advisor, saying that this is the advice I gave to the team. If you agree, good enough. If not, let me know so that I can fix my next upcoming advices. The next step will be building. So as soon as the team already understand what security features they need to build into the solution, the model will actually understand, okay, now you're starting to code. I will read this code and also think about, okay, these were the user stories created or these were the recommendation. Based on this, are you creating the right code or are you creating the right features in your code or not? And if you're not, then it will also provide the recommendation that you're missing so-and-so code. So if there is a possibility of getting injection type attacks later, the model will already understand that based on your coding practices and then recommend that to the team itself. And the same time, the real feedback also goes to the security team, explaining them that this is the feedback given to the team. So here what is happening is, as you see that for the process 1 and process 2, usually the teams will set up time with the security person, and as we know, most of the security person are spread thin. They also have to spend time in researching the technology that the team is using to create their product, and the technology is changing so fast. Security teams need to be on top of their toes to really understand the new technologies coming in, do the research of what security implications or issues can happen there, and based on that, respond to the team. We cut down all that time by the tool doing the research for the security team and providing them the feedback already. And in the final stage, when we test the solution itself, let's say, for example, for a lot of applications, usually pen testing kind of exercises or CI/CD based pipeline testing are happening for a lot of solutions. What we can already observe is for some of the research that we did, we observed that there was a faster time for fixing the security issues because there were lesser number of security issues in the final software which was developed as well, and which eventually helps the business to bring the new features to the market as soon as possible. But this is not something that can fix all your problems. So there are some challenges or limitations for using this. So one is higher initial cost, because you have to train the model, you have to fine-tune the model, you have to identify the right knowledge base. So maybe you have to pay for that knowledge base, or sometimes if you already have the knowledge base, you need to collate it within your company. Then for small businesses or small scale applications, it's a little bit challenging to have that investment already within the day one of the solution. Latency and performance, if you put something on a GPT, which is publicly available, you might get the responses in a second or 2 seconds. But these kind of decision pipelines take a little bit more time. I'm not talking about like hours, but maybe 30 seconds to a minute or 2 minutes to understand the solution, to understand the product that you are developing, run all the decision pipelines, and then give you the recommendation. And dependency on the ecosystem. So once you create this ecosystem within your organization, let's say, for example, you chose Azure or you chose AWS, then you're kind of stuck in with that technology for using it, because as per my understanding, none of them are actually working platform independently. So if you create a solution which is using Azure Cognitive Services, for example, you cannot just directly move to AWS. But that's not all dark. There are some advantages of this as well. So one of the advantages is contextual accuracy and customization. So the results that you get are really good, and also you can customize the language of the output towards what your industry or your company is used to. So that becomes really easy for your users to consume. The second one is the reliability and traceability. Within a lot of companies, when we during the research, when we were talking to them, they were telling us that, okay, we can get the same results from GPT, but the problem that we have is if we make a decision based on the response given to us by an AI engine, for now, it's already questionable enough to say that how you made the decision. But going forward with the EU AI Act, for the AI models, you need to also provide traceability and auditability of how you are making your decisions. So for that, it's really important to understand each stage where the decision is being made and what are the repercussions of that decision along the pipeline. Third one was control over your data security and compliance. This entire solution can be enclosed within a VNet virtual network environment, where you can take the data residency or the complications of the risk of exposure of data all inside your organization, and you can control it better. And the modularity and flexibility, provides you, for example, if you have any regulations which are new to the market, you just need to let the model know, like this is new regulation which is coming in. Just provide that contextual information to the model, it will understand that. When to choose this kind of architecture solution versus a normal GPT, LLM-based solution? If you need really high accuracy within your organization, if data privacy is a big concern for your organization, if you're working in regulated industries, for example, financial, oil and gas, or even nowadays, most of the organizations, or at least big organizations, are coming under the DORA Act or under the NIS2 Act. So a lot of companies are being regulated in this area as well. And where you're handling sensitive data of your company, where you cannot trust a publicly available SaaS solution for giving them your data or the keys to your kingdom. When not to, maybe if you have a really small team developing a small solution, simple solution, this might not be a good approach for you because it might be too costly to do all this activity for that kind of solution. So these were some of the learnings and the results that we got from our research and the work that we did for some of the organizations. At the end, I would like to say security isn't something that is an afterthought. We are trying our best as DevSecOps professionals, as security professionals, to integrate it as a basic part of the software development process. Thank you. And I'll have some time for questions if you have any.
Yes, if you have any questions for Spandan. Yes, please.
Thank you for the talk. It's really interesting.
Thanks.
Taking a lot home. The question I have is, what about use cases for do you have any use cases for the genesis of a product or product increment, like business side professionals can use in order to actually check whether that is a possibility? Because the corporations also have you have either legacy code or the technology you're using is not capable of carrying out your desires. So maybe they get to that early, like
Indeed.
Shifting left to the business side in an easier way to tell them, you're not being compliant to certain laws, and plus we don't have the technology prepared to endure what you're asking.
Support what you want. Yeah, that's a really good question and suggestion to us actually to think in that direction. We did have some discussions when we were thinking about a pre-privacy assessment solution, of thinking about if you develop anything, if it is going to implicate you for GDPR, what do you need to think about when you are even designing the business feature of the solution, not even thinking about the technological aspect of it. That's really good addition to that. We can think about that. But the other part is, like you mentioned, that there are some technological limitations within your company or the infrastructure limitations with your company. So when you make the model aware of your company environment, the model already knows what technology stack you're using and what the limitations are. So it would be just a matter of putting an application level wrapper around the model to say that, okay, I want these kind of outputs now. But that's a really good addition to it. Thanks.
Any other questions? Cool.
Thank you.
Thank you so much, Spandan.